Good evening, Miss Young here. This is video 2 in the series on converting a number between 0 and 255, or a decimal number, to hexadecimal. At the end of the last video, we had a quick look at how to do this on paper, and today we're going to put this into practice. So I'm just going to clear the screen and close the toolbar so that we can move forward with how to do this. First of all, as I said, in OCR exam reference language. So looking at the question, this is pretty formulaic, how to enter a number and validate it. Well, we want a decimal number. We could just write number, but in this particular case we want a decimal number. So I'm going to write decimal number. And we want to enter a number between 0 and 255, and then we want to say that while that number is less than 0, or that number is greater than 255, then we want to effectively do the same thing again, but we'll put a message that says invalid entry, and we can end well. I'd have to forgive me, it's a while since I've done exam reference language, but the problem is that in ERL, just like in Python, this will always return, input always returns a string. So we're going to need to cast that to an integer both here and both here. And let's just print the number just so that we can see if everything is working as it should be. And now, of course, it's giving us a typo. So let's just fix that, of course. ERL, while this likes lowercase, for some reason it wants an uppercase in the or, and so we'll start with some invalid number. It's telling us it's invalid. We'll put 255 in, and you can see that was at the limits. So all seems to be good so far. So we have a number, and so we said in the previous example that in order to get the first digit, we needed to take the integer division. So we can say, I'm going to just call it digit 1 is equal to the number which we wanted is d number, and we said we wanted to take the integer division of that by 16, and we then said that we want to take the second digit and take the modulus of that. And just so we can see, we're going to print digit 1, and we'll print digit 2, and if we remember, we had 1 and 4. If we put in 20, that should return 1 and 4, which it does. And if we run this again, and remember, if we put 42, it should give us 2 and 10, which it does. But of course we have a problem. This is not what we want. We want A. So at least we know so far this is working just fine. So now we can ask ourselves, how can we do this? So I said to you there is a number of different ways, and we're going to do it in different ways, but I'm going to show you what I think is the easiest, although in actual fact the longest way of doing it, because we can ask ourselves this question: if digit 1 is greater than 9, then we need to do something, don't we? Well, before we do that, let's just make, what do we want? Let's make, we're going to call it, I'm going to call it h digit 1 because that's a string, and I'm going to immediately convert that to a string, because the reality is that in 10 out of the 16 combinations it's always going to be just fine. If we have a 0, then we want a string 0. If we have a 9, we want a string 9. It's only if the digit 1 is, or digit 2 is greater than 9, do we want to do something. So what can we do here? Well, we can say if it's greater than 9, then we can use a whole host of ifs, or we can just say switch, and we want to switch on digit 1, and for some reason ERL wants a colon here, and then we're going to go case of 10, and we want H digit, in this case we want to override H digit to be equal to A, and we want 11, 12, 13, 14, 15, and we don't want 16 of course, and then we can have end switch and end if, and then now we just need to move this to be 11, 12, 13, 14 and 15, and now I know if I enter FF, that should be, 255, that should be FF. So what I'm going to do here is I'm going to, no, I don't want to console. I want to print H digit 1 plus H digit 2, and these are strings, so that should work just fine. Of course, this should output F15 because we haven't done anything with digit 2 yet, but let's just see what happens if I enter 255, and what do we get? We say H digits, that's because I can't spell. You can see, let's try that again, and put in 255, and we get 15, 15, and of course again we need to mind the variables. Let's try that one again. Now we get F15. So again, now of course, like I said, if you're doing this in code, it's a really quick fix now to change this to be the digits 2, and hopefully if we run this now and we put in a 42, that was, if you remember, that would be 2A, and that is correct, 2A. If we put in 20, that should be 14, which is correct, and if we put in 255, that gives us FF. So this piece of code is working just fine. So the first thing I'm going to do is just simply make this into a procedure, and I'm going to call this decimal to hex, and I'm going to call it 1 because we're going to run, I'm going to show you in a number of different ways how we can do this, keeping in exam reference language. And so again, if I just call a decimal to hex 1 here, hopefully I put in, as I said, 42, it gives me 2A. So now I have this des to hex. All I'm going to do is I'm going to copy that, and I'm going to simply create des to hex, and I'm going to change that to 2 here. So this piece of code is never going to change. This piece of code, it might change, but for the moment we're going to keep it as it is. What we don't want to do is all of these lines here. So the question is how can we fix that? Well, like I said, we're going to go through what I would call, this is a slightly shorter than the previous text, but this in fact requires quite a bit of thought, because what we can do here is we can set up a constant, and we can set the offset, and I'll explain what this is doing in a minute, to equal the ASCII value of capital A, but because we're starting at 10, we want to take 10 off that. So what we're going to do here is, again, we're going to simply say, set these to be the same, and again, we're going to say if a digit 1 is greater than 9, but this time what we can do is we can say that the h digit is equal to the character at digit 1 plus our offset. So what's happening here is that if our digit 1 is 10, then we're taking 10 off that, which gives us 0, and then we're adding on, in this case, 65. That's what ASCII A is. If we know that, we can just write 55, but that will be more than it's obvious what you're doing if you do it that way. And so I can just copy and paste that, and I can ask the same question, and of course that should be h digit 1, and that should be h digit 2, that should be digit 2, and now if I run decimal to hex number 2, okay, and it says constants, is it const? Try running that, there we go. If we put in a 255, it should be FF. I've put in 42, we know it should be 2A. So we know that that code is working just fine. So we've gone from all of that. Of course, it was very, very easy to do when we were typing it, but if you have to write this by hand in an exam, there's a lot for you to write. And so this is a little bit shorter, but we can make it even shorter still. So again, I'm going to copy decimal to hex, and I'm going to create a third version, and we can do this particular version in OCR exam reference language, and we can do it in Python, C#, VB, Java, JavaScript, but interestingly, you cannot do this particular one in, well, you can, but you can't do it in less lines because it's so much more. Initializing arrays in Cambridge IGCSE is just pain. So here we're going to write array, and then we're going to call it a lookup table, and that equals, and you can find this in the OCR exam reference language, it is a valid way of initializing an array. I'm just going to count through this, not 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, and we can now look and say 1, 2, 3, 4, 5, 6, 7, oops, 8, 9, 8, whoops, I want it capitalized, A, B, C, D, E. Let's just check that. No, 1, 2. Oh, you see, look at that. I missed a 3. 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. Double check where I've gone wrong here. 3. And this is not looking particularly, oops, I'm looking at the wrong part. So we can get rid of that at the end. Not 1, 2, 3, 4, 5, 6, 7, 8, 9, and F. And we can now actually get rid of all of this, and we can use this lookup, and we can actually say, we don't need this string anymore, we can actually just say it is the what do we call it? Lookup table at index of digit 1, and we can change this one to be at digit 2. Now, this is how to write it in exam reference language. Unfortunately, one of the areas that this interpreter doesn't quite work yet is it won't accept lookup table or this array initialization like this. So to make this work, we need to just remove that. If I again put 255, you'll see that we get FF. If I put in here 42, we get 2A. And so the reality is that we have, by adding this, which doesn't take very long for us to write, certainly means not writing case A, case 0, case 10, case 11, case 12. We can do it in this manner. And so, like I said, technically speaking, this is how it should be written in ERL, and this is how it works in, and it will be a very nasty examiner if they marked this down correctly, but if you're handwriting it, make sure to do that. And of course, I wouldn't, but if you really desperately wanted to save yourself some time, here you could just put that into one line here and save yourself even more writing. And of course, you can see that this particular version is very much more efficient than the others. So that is how we would write this question in exam reference language. I'm going to just take that back to where it was. A minute to here. Let's just double check that's running again. 42. Okay, so there we go. Of course, we just need to get rid of that. Hopefully that's the problem. This doesn't have the best record with a Control Z and Control Y, or delete, undo and redo, but there you go. And so one question that some people might ask is, well, we could just forget. Let's go back to this particular version and run decimal to hexadecimal 1. Some people might ask the question validly, why would we bother with this? We could in fact say and in OCR reference language we have something called default, and we could say that the default is this, and we could add that in again, and that would be fine. There's no point then again having the ifs, because now we are currently not sure why it's decided to move to the next stage, but that's fine. And we want to just move that back to here, and of course this should be digit 2 and this should be digit 2. So what happens when I run that? If I enter 255, now it works, but what we haven't done is we haven't considered the fact that we already in fact did this here. So we need to remove these two lines of code, and then if we run it again, 255, and you'll notice that it says could not locate variable h digit 1, and that's because of scope. You see, when we create h digit inside of here, inside of the switch, it belongs only to the switch. So when we get to here, this h digit 1 has not been defined outside of the switch. It has only a local scope. So if we were in another language, for example C# or a Visual Basic, or even IGCSE, Cambridge, where we would declare a value, then we could do that. But as you'll see here, I would need to, out here, I would need to say, for example, well, I'd have to say H digits is equal to an empty string, H digit 1 and H digit 2. Then hopefully you'll notice that it does work. Or if you could, but we don't, again, exam reference languages like Python, we do not declare. If we could say something like int, but of course the int is a keyword for converting. If we could do declare, but that's not a keyword either. And so in this particular case, it makes far more sense to put these two values here with the if statements that we originally had. Like I said, unfortunately for some reason, when I press Control Y or Control Z, it's not working how I would like it to work, but that is just fine. Now, of course, again, we might argue, well, if we're already presetting it, why would we want to do even an if statement? Well, of course, as I said, 9 times out or 10 times out of 16, this is not going to be required. However, again, in an exam, it would be a very tough examiner who said you only do that if the digit is greater than 9. But it would be safer to say if not H digit, if digit 1 is greater than 9, then indent and do an end if. This would be the most likely to get all of the marks, assuming you are going to do it. Oh, sorry, again, I've got Python in my brain here. Then end if here. And so, like I said, while this is a long way to do it, it is a very straightforward. Essentially, convert them both to digits, and if the number happens to be greater than 10, just do that. Or if you really wanted to be, or you forgot about how to do a switch, then of course you could write if digit, well, in fact you wouldn't even need that one. You would say if digit 1 equals 10, then what would we say? We'd say then hexadecimal digit is equal to A, and you could do that. Of course, if you're in ERL, you can do else if and keep going in that way. But again, that would be a horrible way. A switch is a much nicer way to do that. So I hope this has been helpful. The next video we're going to do and copy this code into exam reference language. So I'm just going to put this back to how it was, and we'll put this in exam reference language. I'm Miss Young. Hope that that's been helpful for you. Good night.